Mabuhay everyone! Welcome back to our math class. So for today, we are going to have our last video discussion in preparation for our upcoming fast math. So please finish watching the video, complete it just in time for Pythagorean Theorem and angle relationship. Listen attentively and copy the solutions for every questions. So we are going to focus our review for this day with our lesson on angle relationship and Pythagorean Theorem. So these are all our goals, and I hope that you have learned this one before, and we are just going to recall. We're going to recall on Pythagorean theorem, how to use them in solving mathematical and real-world problem. We're going to use it to find distance between 2 points. We will also have triangle inequality for us to determine our triangle from the given sides and the converse of it. And we are going to have problems involving angle relationships. So we are going to focus on this benchmark for today. Okay, so as a short review, remember we have different kinds of angle relationship. We have the first one, supplementary angles. They add up to 180 degrees. Okay, somehow if they are adjacent, they form a line. That's why we also call this one a linear pair. Okay, linear pair also add up to 180 degrees. Okay, complementary angles, they add up to 90 degrees. As you can see, they form a right angle if they are adjacent. Remember, in supplementary and complementary, it doesn't necessarily mean that they are adjacent to each other. As long as when you add them, they sum up to 180, it will be supplementary. They sum up to 90, it will be complementary. We also have vertical angles. These are angles that is formed by intersecting two lines. They are across from each other and they are congruent. Remember, when we say congruent, they have equal measure. Okay? And we have adjacent. They are simply next to each other because they share a common side and a common vertex. But we cannot say anything about their measurement, only the position. Okay, we are also going to use Pythagorean theorem for today. So as you can see, we use that one to find the missing side length in a right triangle. Okay, if you recall, hypotenuse, our C, is the longest side of our right triangle. And our legs, A or B, they can be interchanged, are what we call the legs. Okay, we can use this one to find the distance between 2 points as well and find our missing side in a right triangle. Remember, this is only good for right triangle. We will also use what we call the triangle inequality theorem. So remember, we use this one to identify if the given three sides can form a triangle. Okay, because in triangle inequality theorem, it says that the sum of the two shortest sides must always be greater than the long side. Like for example, this one. Our small medium, 3 plus 5, will give us 8, and that is bigger than 7. It's only enough to say that in triangle inequality theorem, if the measurements are not arranged in smallest to largest, remember, the sum of any two sides should always be bigger than the third side. Okay? Bigger, not equal. Okay, we will also use our interior and exterior angles of our triangle. Remember, the sum of the three angles, interior angles of our triangle is 180 degrees. Okay, so angle A plus angle B plus angle C is 180. For our exterior, we can have an exterior angle if we extend one side of our triangle. And as you can see here, our exterior angle, this is what we call exterior angle, and one of the interior angle form a straight angle, so they are supplementary to one another. So they are equal to 180 degrees. That is one way on how to find the measure of our exterior angle. We also have this one. If I have two angle x and y, we call this one remote interior angle. We can also use this one to find the measure of our exterior angle because the exterior angle theorem says that the sum of our two remote interior angle will be equal to our exterior angle. So angle x plus angle y is actually also equal to angle A. So we can use that one later on in solving angle relationship problems. And then finally, we are going to recall the sum of interior angles of our regular polygon. So remember, we applied this one before by finding out how many triangles we have in a polygon. Okay, so therefore, and we also derived that to find the sum of the interior angles of our polygon, we only use the formula n minus 2 times 180. n minus 2 determine how many triangles in a polygon, wherein n is our number of sides. And then times 180 degrees. So we apply this one to find the sum of the measure of the interior angle of our polygon, any polygon. Okay, so let's dive into our first review question. Number 1. Use a diagram to answer the question below. So part A, which angle relationship is represented in the diagram above? As you can see here, they form a right triangle. Okay, and as we all know, when we say a right triangle, this is exactly 90 degrees. So therefore, for this one, our answer is complementary angles. Because remember, complementary add up to 90 degrees. Supplementary add up to 180. Vertical, they are equal. Part B, determine the value of x. So we can apply this angle relationship to find our x. Since these two angles are complementary, the sum of these two angles will be 90 degrees. So we can have our equation will be 5x minus 10 plus 22 is equal to 90. So we solve for x like how we solve linear equation. We can combine negative 10 and 22. So we'll have 5x plus 12 is equal to 90. To isolate 5x on our left side, we have to eliminate positive 12 by getting its inverse. So the positive 12 plus 12, the inverse is minus 12. So we minus 12 on both sides of our equation. So 5x is equal to 90 minus 12 is 78. And then finally, we get the inverse of 5x, which is division by 5. So you have x is equal to 78 divided by 5 is 15.6. So our x here is 15.6. Okay, so it's very easy to answer questions involving angle relationship if we know their relationship. Okay, okay, let's move on to question number 2. Okay, question number 2 is also about angle relationship. So the sum of the adjacent angles in the figure is 164. We're going to find the measure of these two angles. Since we are given the sum, which is 164, we can create our working equation as 8x plus 2 plus x is equal to 164. Okay, so our angle WZX is 8x plus 2, while our XZY, angle XZY is our angle X, equal to 164. Now let's combine similar terms. 8x plus x, that will give us 9x, plus 2 is equal to 164. Getting the inverse of plus 2, we minus 2 on both sides. So you have 9x is equal to 162. Then finally, we divide both sides by 9. So our x is equal to 18. So as you can see here, okay, our WXZ is x. So therefore, our WZ, our XZY is x. So therefore, our angle XZY is 18 degrees. Okay, to find the measure of WZX, that is equal to 8x plus 2. Then since x is equal to 18, we can have here 8 times 18 plus 2. Okay, 8 times 18, that will give us 144. Okay, plus 2. Therefore, our angle WZX is 146 degrees. So this one is 146 degrees. Okay, so again, that is the relationship between these two angles, and we have found our angle measurement using that one. Okay, moving on to question number 3. So what is the measure of angle ABC? Okay, so we are looking for this angle ABC. And as you can see here, we have two angles DBC and ABC. They form a straight angle. And as we all know, straight angle are supplementary, so their sum is 180 degrees. So we can make our working equation as 16x plus 2 plus 10x minus 4 is equal to 180 degrees. Okay, because their sum is 180. So combining similar terms, 16x and 10x, that will give us 26x. And then you have, okay, 2 and negative 4, that will be minus 2 equal to 180. And then applying the inverse of minus 2, we have plus 2 on both sides of our equation. So you have 26x is equal to 182. And then dividing both sides by 26, so our x will be equal to 7. But we don't stop here because we are looking for the measure of angle ABC, which is equal to 10x minus 4. So replacing x with 7, you will have 10 times 7 minus 4. That is 70 minus 4. So therefore, angle ABC is 66 degrees. So this one is our final answer. Angle B is 66 degrees. Okay, so there you have it. Those are the solution on how to find this angle ABC given this figure. Now, moving on to question number 4. For question number 4, as you can see here, we are given a right triangle. So therefore, to find our missing side A, we are going to use our Pythagorean theorem. So we're going to use the Pythagorean theorem for this one. So remember, the Pythagorean theorem says that A squared plus B squared is equal to C squared. Okay? So we are given this is our C, this is our B, we're looking for A. So remember we will have, okay, A squared plus 15 squared is equal to 18 squared. So we can actually do this one. A squared is equal to 18 squared minus 15 squared. And we can get the square root of both sides here. So we will have A is equal to the square root of 18 squared minus 15 squared. If you're going to press it in your calculator, that will be the square root of 99, and that will give you, okay, 9.9. So therefore, our A is 9.9 units. Okay, so again, this one, you can press it in your calculator to come up to 9.9, since we are allowed to use the fast calculator during the test. Okay, moving on to question number 5. So which equations correctly relate the angle measures shown in the diagram? Select all that apply. So as you can see here, we have vertical angles that we can use. These two and these two are vertical, so they are equal to each other. So therefore, if we have 9x minus 5 equal to 8x plus 10, that will be correct. Okay. Also, these two are vertical to one another. Okay. 3x plus 5 is actually equal to 5x minus 25. So this one is also correct. Okay. So 3x plus 5 is not equal to 9x minus 5. So we cannot check this one. 8x plus 10 and 9x minus 5, they are equal because they are vertical. So their sum is not 180. 5x minus 5 and 8x plus 10, this one, okay, this one and this one, they form a straight angle. So they are supplementary. The sum is 180. So that is also correct. So correct for this one. Okay, because they are supplementary. Okay, for the next one, 3x plus 5 plus 5x minus 25. Again, they are vertical, so they are not equal to 90 degrees because they are equal. Okay, so that's why we have to remember the angle relationship so that we can make some conclusion out of our diagram. Okay, moving on to question number 6. So this one is an application of our Pythagorean theorem. So the locations of a middle school and a high school are shown in the diagram. Currently, drivers must take Hill Avenue, okay, and Main Street to go to our high school. Okay, the city is proposing a new road, Valley Road, right, as shown in the diagram. So if we build this new road, okay, how much shorter would the route between the two schools be along Valley Road? Okay, because as you can see here, the original way, okay, is actually 2 plus 3 kilometers, so 5 kilometers, right? Let's find out, okay, what is our proposed Valley Road. So as you can see, this one is C in our right triangle. So to find our C, remember, we will have the square root of A squared plus B squared. So C is equal to 2 squared plus 3 squared. This is our A, this is our B. So C is equal to the square root of 4 plus 9 and that is the square root of 13. So C is, actually, that is 3.6. Okay, so this one, the proposed road will only take 3.6 to travel from middle school to high school. Okay, but we are asked how much shorter. So we have to subtract 3.6 from our original distance, which is 5. So the answer, it will be 1.4 kilometers shorter. Okay, so 1.4 kilometers shorter than the original route. Okay, so you have to be careful as well, okay, in understanding what is being asked in our problem, okay, because some of you might think, oh, it's the answer is D, 3.6, because applying our Pythagorean theorem, we get the value road as 3.6. However, if you look at the question, how much shorter, so we have to subtract it still to our original distance. Okay, moving on to question number 7. Question number 7. What is the distance between 3 and -4 and then 5 and 1 on the coordinate plane around to the nearest, okay, 10? Okay, so for this kind of question, right, if you have a graphing paper, then you can graph it, okay? But if you don't have, we can actually get the vertical distance or the horizontal distance for every point, right? So for example, here for our 3 and 5. Okay? From point 3 to point 5, the distance is actually, let's say this is, okay, let's imagine that we have our coordinate plane. Okay? So this is 3, -4. So this one is 3, -4. And then 5, 1 will be on this side. Let's say 5, 1 will be here. Okay? If we're going to connect that one right here, okay, that will be our distance, C. But if we're going to make our right triangle here, okay, we can actually find the distance between, okay, our x's, 3 and 5, right? So 3 minus 5, that will be 2, right? So let's say this is 2. And then for our y distance, that is -4 minus 1, that is -5. But since it's distance, we get the absolute value. As I've told you, it will always be positive because it's a distance of a number from 0. So that one is 5. Okay? So we can say that our A is 2 and our B is 5. So to get our distance between these 2 points, so you will have C is equal to the square root of A squared plus B squared. So you have, okay, 2 squared plus 5 squared. And that will give you 4 plus 25. And then 4 plus 25 is 29. Getting the square root of 29, the answer will be 5.4. So this will be the distance between these 2 points. Okay? So again, you can actually find the distance, okay, for our A and B by getting the horizontal distance, subtracting the x, and also the vertical distance, subtracting the y from each other. Remember, it's always absolute value, so it's always positive. Okay, moving on to question number 8. Two ordered pairs are graphed on the coordinate grid. What is the distance between these 2 points? So as you can see here, if we are going to draw a right triangle, okay, the distance that we talk about here, this is our right angle, is our hypotenuse. So counting our vertical distance, you got here 1, 2, 3, 4, 5, 6, 7, 8. The horizontal, 1, 2, 3, 4, 5, 6. Okay? So our A is 8 and our B is 6. To get C, we get the square root of A squared plus B squared. So we have here 8 squared plus 6 squared. As you all know, that is 64 plus 36. 64 plus 36 is 100, and the square root of 100 is 10. So therefore, our distance is 10 units. Our hypotenuse will be 10. Okay, again, you can press the square root of 64 plus 36 in your calculator, and it will automatically give you 10 as your answer. Okay, moving on to number 9. Another application of the Pythagorean Theorem. So two parallel sidewalks are shown in the grid. Okay, what is the perpendicular distance between the two sidewalks? When we say perpendicular distance, we are looking for this one. Okay, our C. Why C? Because as you can see, we can form a right triangle out of that. This is our right angle. So like a while ago, let's count our horizontal and vertical distance. So you have 1, 2, 3, and also 1, 2, 3. So we're looking for C. That will be the square root of A squared plus B squared. So here we have A and B equal to 3. So 3 squared plus 3 squared. So you will have here 9 plus 9. And that will be the square root of 18. So therefore our C is equal to 4.2. So the perpendicular distance between the two sidewalks is 4.2 units. Okay, now let's move on to question number 10. Which of the following sets of the measures the side up are the measures of the sides of a right triangle? For this one to be a right triangle, remember we have to follow the Pythagorean theorem. Okay, they have to follow that a squared plus b squared should be equal to c squared. Okay, so let's take a look, for example, for the first one. This is 9 squared plus 15 squared. Is that equal to 20 squared? Okay, that will give us 81 plus 225 is equal to 400. And 81 plus 225 is equal to 306, which is not equal for 400. So therefore, this is not, a right triangle. Let's try the next one. So we have 4 squared plus 7 squared. Is that equal to 9 squared? So 16 plus 49 is equal to 81. 16 plus 49, that is 65, not equal to 81. So it's not. Okay, let's have the third one. That is 10 squared plus 12 squared equal to 18 squared. 100 plus 144 is equal to 18 squared is 324. 100 plus 144 is 244 only, not equal to 324. So they are not the same. Okay, let's move on to the next one. Okay, 8 squared plus 15 squared plus is equal. Okay, is equal to 7 squared, 17 squared. So that is 64 plus 225 equal to 17 squared is 289. 64 plus 125 is 289 equal to 289, and that is a right triangle. Good job. Let's have the next one. This one is 5 squared plus 10 squared is equal to 12 squared. So you have 25 plus 100 equal to 144. Obviously, this is not a right triangle because 125 is not equal to 144. Let's have the final one. We have 10 squared plus 24 squared. Is that equal to 26 squared? So 100 plus 24 squared is 576. And then 26 squared is 676. And I think we have another right triangle. 676 is equal to 676. That is correct. Okay? So again, do not be disappointed because we have a calculator that will help us to solve this one. Okay, so all you have to do is to press it in your calculator. Okay, moving on to question number 11. So you just have to be patient. Okay, complete the chart that indicate whether the three sides form a triangle or not. Okay, so remember for this one, the sum of the two sides must be greater than the third side. Okay, so as you can see here, when we add 5 plus 2 and 9.3, that is simply equal to 14.5, and that is less than 15.1. So this one doesn't form a right triangle. Here, 122 and 140, that will only give you 162, and also that is less than 277. They do not form a right triangle. For the next one, 8.3 and 8.1, that will give you 16.4, bigger than 13.9, so therefore they form a right triangle. 23 plus 23, that is 46, that is bigger than 41, they form a right triangle. Okay, remember the sum of the two sides, must be greater than the third side. The sum of any two sides, must always be greater than the third side to form a triangle. Okay, let's move on to question number 12. A triangle is shown. Use the drop downs to make the statement that is true. So as you all know, the sum of the angles of our triangle is 180 degrees. So we can actually form our equation: 3x plus 10 angle A plus 2x plus 20 angle B plus x plus 30 angle C is equal to 180 degrees. Okay, so let's combine all our similar terms: 3x, 2x, and x. That will give us 6x. 10, 20, and 30. That will give us 60 is equal to 180. So solving this linear equation, we get the opposite of positive 60, which is negative 60. So you have 6x is equal to 180 minus 60 is 120. We divide both sides by 6, so therefore x is 20. So our x value is 20 degrees. Therefore, what is the measure of angle A? Angle A is actually 3x plus 10. So it means 3 times 20 plus 10. 3 times 20 is 60 plus 10 is 70 degrees. So angle A is 70 degrees. What about angle B? Angle B is 2x plus 20. Since x is 20, you have 2 times 20 plus 20. 2 times 20 is 40 plus 20 is 60. So angle B is 60 degrees. Okay, so we have to be patient in solving our problems. Okay, moving on to question number 13. Two sides of our triangle have lengths 11.3 inches and 15.9 inches. Which of the following could be the length of the third side? Remember, we have a clue here, okay? To get the range of values that will be okay to be the third side, we have to find, let's say first, the difference, 15.9, okay, minus 11.3 is equal to 4.6. So we are looking for a number that is bigger than 4.6. And then we get the sum, 11.3 plus 15.9, which is 27.2. Bigger than 4.6, but smaller than 27.2. So among all of this one, okay, bigger than 4.6 and smaller than 27.2 will be these sides. The rest will not be possible sides of our third side. Okay, that's easy if you know this one. Okay, moving on to question number 14. What is the measure of angle 1? Okay, as you can see here, angle 1 is our exterior angle. There are actually two ways on how to get the answer for this question. Okay, we can actually find this A first. To get A, we have 180 minus 108 because they form a supplementary angle, linear pair. So that one is actually 72 degrees. 72 degrees. Since angle 1 is our exterior angle, okay, remember angle 1 is actually equal to the sum of angle A and 37 degrees, our two remote interior angle. So angle 1 will be equal to 72 plus 37. So angle 1 is actually 109 degrees, and that is letter D. Okay? You can actually get this angle, but after getting that angle, you will again minus from 180. So it's easier to do this way. Okay, moving on to question number 15. So a figure is shown, find the correct number in each box. So we're going to find the measure of angle, these three angles. So as you can see here, this one is our exterior angle. This one. And these two are our remote interior. For the exterior angle theorem says that the sum of our two remote interior, 2x plus 20 plus x plus 10, is equal to our exterior angle. That is our working equation. 2x plus 20 plus x plus 10 is equal to 120. So combining similar terms, 2x plus x is 3x. 20 plus 10 is equal to 30 is equal to 120. So we subtract 30 on both sides. You have 3x is equal to 110. Oh, sorry. 120 minus 30 is 90. Then dividing both sides by 3, x is equal to 30. Okay, so angle, our x is equal to 30. Let's find angle QPR. Angle QPR. Angle QPR is this angle that is equal to x plus 10. So it will be 30 plus 10 since our x is 30. So angle QPR is actually 40 degrees. So this is 40 degrees. Next, our angle PQR, this one. So angle PQR is 2x plus 20. Our x is 30, so 2 times 30 plus 20. So you have 60 plus 20, that will give you 80 degrees. Angle PQR is 80 degrees. Now, where is angle PRQ? PRQ is this missing angle here, right? As you can see here, let's say the sum of the angles of the triangle is 180 degrees, but you can actually form this one as a as a supplementary angle. So therefore, angle PRQ is simply equal to 180 minus 120, and that will give us 60 degrees. So this one is 60 degrees. Okay, so there you have it. That is how you find the measure of the missing sides or the missing angles of this given triangle. Okay, now let's move on to question number 16. Okay, so for question number 16, we are asked to find the measure of angle 1. Okay, so as you can see here, our angle 1 is this one.
At this time, we are
Okay,
going to
and
dismiss
this
third
2 will
floor.
give
At
us
this time, we
180
are going to
degrees.
dismiss third floor.
However, before
Thank
we
you
can do
for
that
your
one, we
position.
have
Have
to
a great
find
day. We
our
will
x
see you tomorrow.
first. So as you can see, this is our exterior angle, and then this 2 will be our remote interior angle. Just like what I said a while ago, the sum of the two remote interior, 3x plus 13 and 35, will be equal to the exterior angle, which is 5x minus 16. So solving for this one, let's combine for similar terms on our left side. So 13 plus 35, that will give us 48. So 3x plus 48 is equal to 5x minus 16. Since we have two variables on sides of our equation, so we eliminate the smallest one, which is positive 3x. So we get the inverse of that. So we minus 3x on both sides. So we will have 48 equal to 5x minus 3x is 2x minus 16. To eliminate 2x on the right side, we remove negative 16. So we get the opposite, the inverse. So we add 16 on both sides of our equation. So this will become 64 is equal to 2x. Then finally, to solve for x, we divide by 2. So therefore, our x is 32. Okay? Since our x is 32, we can find the measure of 5x minus 16. So 5x minus 16 will become 5 times 32 minus 16. Okay? 5 times 32 will give you 160 minus 16. That will give you 144. 160 minus 16 is 144. So therefore, this exterior angle is actually 144. So remember, angle 1 and the exterior angle made a linear pair, so the sum is 180. So to get angle 1, finally, we will have 180 minus 144. So therefore, the answer is 36 degrees. So angle 1 is 36 degrees. So remember, in solving problems involving angles, sometimes you have to find other missing angles before we can find what we are looking for. So be patient and solve on how you do it this one. Okay, moving on to question number 17. So a figure is given below. We are going to look for the value of A. Okay, as you can see, this is our A. Okay, so looking at this one, you can play around by getting the relationship between the angles here. So 2x plus 6 and angle A. Okay, as you can see, this one is also 6x plus 4 because these two are vertical angles, right? So if we can find 6x plus 4, and add it to 40, then minus from 180, we can get our angle A. But before we get our angle A, we have to get our x first. So to get x, we can use this exterior angle and then this two remote interior. So remember, the sum of these two remote, 6x plus 4 and 2x plus 6, is actually equal to 154. Okay? So simplifying our equation, 6x plus 2x is 8x. 4 plus 6 is 10 equal to 154. So we subtract 10 on both sides. So you have 8x equal to 144. Dividing by 8. So x is equal to 144 divided by 8 is 18. So our x is 18. So let's find 6x plus 4. So 6x plus 4 will be equal to 6 times 18 plus 4. So 6 times 18 is 108 plus 4 will give you 112. So this angle is 112. So to get our angle A, we have 180. The sum of the three angles of a triangle is 180 minus the sum of 112 and 40. So 180 minus 112 plus 40 will give you 152. So therefore, 180 minus 152 is 28. And that will be our A. So A is 28. So this one, 28. Okay, so we have to learn how to play with the given angle so that we can use those things, those relationships to find our missing angle. Again, be patient and exert effort. Don't worry, you got this. Okay, let's go to question number 19. For number 19, what is the measure of angle Q? So angle Q is this one, 6x minus 5. As you can see here, we are given a quadrilateral. We have 1, 2, 3, 4, a four-sided polygon. Before we can find our x, we have to know the sum of the interior angles of our quadrilateral. Okay? Remember our formula? We have n minus 2 times 180. So for this one, we have four-sided, 4 minus 2 times 180. That will give us 2 times 180. So the sum is 360 degrees. So when we add all these four angles, the sum will be 360 degrees. So let's make our working equation to solve for x. So you have 6x minus 5 plus 5x minus 1 plus 9x minus 4 plus, don't forget this one, that is 90, okay, equal to 360 degrees. So adding all our x, 6, x, 5x, 9x, that will become 20x. Adding all our constant, negative 5 minus 1 minus 4 and 90. So negative 5 minus 1 minus 4 is negative 10 plus 90. That will be 80 equal to 360. So we subtract 80 on both sides. So you have 20x is equal to 360 minus 80. That is 280. And then we divide both sides by 20. So x therefore will be equal to 14. So since we already have our x, we are now ready to find our angle Q, which is equal to 6x minus 5. So 6 times 14 minus 5. So 6 times 14, that is 84. Minus 5, that will give us 79. So angle Q is 79 degrees. So this one. So remember, if you're going to solve problems involving the sides, the angles of our polygons, we have to find the sum of interior angles first. Okay, the formula n minus 2 times 180. Okay, moving on to question number 19. So what is the measure of interior angle for regular 11 gun round to the nearest whole number? Remember when we say regular, all sides and angles, all angles are congruent. So to find the measure of an interior angle of our regular polygon, so we just apply the sum of interior angle. So interior angle of a regular polygon will just be equal to n minus 2 times 180 divided by n, the number of equal sides. So for this one, since we have 11 gone, so 11 minus 2 times 180 over 11. So 11 minus 2 is 9 times 180 over 11. So 9 times 180 will give us 1,620 divided by 11. That is 147.27. But since we're going to round up to the nearest whole number, so our answer is letter B, 147 degrees. Okay, so remember, if you're looking for an interior angle, each interior angle of a regular polygon, find the sum first of the angles of the polygon, the interior angle, and then divide by the number of equal sides. Okay, moving on to number 20. For number 20, what is the value of x? So like what we did a while ago, we need to find first the sum of our interior angles. So let's count the sides. We have 1, 2, 3, 4, and 5. So the sum will be equal to n minus 2 times 180. So that is 5 minus 2 times 180. So 5 minus 2 is 3 times 180. That will be equal to 540. So the sum of these five angles will be 540. So let's make our equation to get our x. So we have 2x plus 4 plus 4x minus 23 plus 2x minus 3 plus 3 plus 3x. Okay, this is plus 3x minus 18 plus 3x plus 6 equal to 540. Okay? So let's add all our x. So 2x, 4x, 2x, 3x, 3x. 2, 4, 3, and 3. So we have a 6 plus 6, so 12x. Oh, wait. Am I forgetting something? 2x plus 4x plus 2x. So 6 and 8 plus 6 plus 6. 14x, sorry. Plus 4 minus 23 minus 3 minus 18 plus 6. Okay, so 4 minus 23 minus 3 minus 18 plus 6 will give us negative 34 equal to 540. So let me just rewrite that one. So it's 14x minus 34 equal to 540. So solving for x, we add 34 on both sides. So we will have 14x is equal to 574 divided by 14, both sides of our equation. So x is equal to 41. So our x is 41 for this one, for this question. Okay, moving on to our last question. So look at the figure, choose the answer from each drop down that makes a statement true. So we have a seven-sided polygon can be decomposed into, let's count the triangles, 1, 2, 3, 4, 5. 5 triangles, okay? 5 non-overlapping triangles. Hence, the sum of the interior angles of a polygon is, since we have a 5 triangles here, so we have 5 times 180. And that will give us 900. So 900 is the sum of the angles, the interior angles of this seven-sided polygon, which is a heptagon. Okay. Okay, so there you have it. This is our review for Pythagorean Theorem and angle relationship. Okay, I hope you copy all the solutions and you listen well to our discussion. Okay, so don't worry. I'm pretty sure you're anxious with the test, but don't worry. Remember, I believe in you. Just believe in yourself. Be patient. Solve. Okay, be persevering when you solve, and you got this one. Okay, no problem. Just put on the thinking cap of yours, and you can answer our fastest very well. Okay. God bless everybody. I will be praying for you. Okay. Remember, I believe in you. Okay. Just believe in yourself. Do your best. Okay. And so that you will not have regrets at the end. Okay. Be patient, believe in yourself, and work hard. Okay. Thank you. And I wish you well in everything that you do.